Hello everyone, welcome to yet another video of measurements and instrumentation video series. In today's video, we are going to discuss about ammeters and voltmeters. So the course outcome for this topic is that we are going to have a comparison about the AC and DC meters along with its internal constructions. We know there are various instruments used in practices. They are in general we use as an electrical students. Very uh, we are in very much need of voltmeter, ammeter, wattmeters, and energy meters. So in doing any experiments, we used to calculate voltage, current, power, and energy. So those kind of meters are used. So let's see what is the operation of these indicating instruments. For satisfactory operation of any indicating instruments, the following three torques must be present together. One is the deflection torque, the other one is controlling torque, and then damping torque. Now let's see what is meant by deflection torque. It causes the moving system of the instrument to move from its position of rest. So from its initial position to the measurement value. To move to the measurement value, it is the deflection torque that moves the pointer. So it is produced by using any one of the following effect, which can be either a magnetic effect or by the electromagnetic induction effect or heating effect or electrostatic effect. Now let's see what is meant by controlling torque. It limits the movement of moving systems. So it provides a balance between the deflection torque and the entire system. It also ensures that the magnitude of deflection is always the same for a given value of input quantity under measurement. The controlling torque acts in the opposite direction of the deflection torque. So during steady state, this deflection torque, which is given by Td, is equal to the controlling torque, which is Tc. Let's see what is meant by damping torque. Due to the deflection torque, pointer moves in one direction, while due to controlling torque, the pointer moves in opposite direction. Due to these opposite torques, the pointer may oscillate in the forward and backward direction if the damping torque is not present. Hence, damping torque brings the moving system to rest quickly in its final position. So, damping torque arrests the pointer to its final position. So, it puts off the oscillations and brings the vibrating pointer to its final position. So, it avoids vibrations in the systems. So it acts only when the moving system is actually moving. If the moving system is at rest, then the damping is zero. Let's see what is critical damping. Depending on the magnitude of torque, damping may be classified as underdamped, overdamped, and critically damped, which we have already discussed in our previous subjects as well as in basic electric circuits. We have seen about all these topics. If the instrument is underdamped, then the pointer will come to rest after some oscillations. If it is overdamped, then the pointer takes considerable time to obtain its final deflected positions. If the damping is critical, then without any oscillations and in a short time, the pointer will reach its final steady state position. So in general, we always prefer critical damping. And this is the graph representing the damping provided for an instrument to bring the pointer to its final position. Now let's see the connection diagram of an ammeter. An ammeter measures current in a circuit, so it is always connected in series with the load so as to measure the current through the load. Since the resistance offered by an ammeter is very small, its introduction in series with the load should not alter the circuit conditions. And also, the circuit connection is being shown here. So here a simple circuit wherein which we are trying to measure the current through the ammeter through the lamp. Hence it is connected in series with the lamp. Now let's see how a voltmeter is connected. A voltmeter is used for the measurement of voltage, which is the potential differences. So it is connected across the points between which the potential difference is to be measured. Since it is connected in parallel, it has high resistance. So it draws a very small current. So the circuit diagram shows how voltage of across the resistor is being measured, and how for that purpose how a voltmeter is being connected. Let's see a short comparison between ammeter and voltmeter. So ammeter measures current and voltmeter measures voltage. An ammeter will also always be connected in series with the load, whereas a voltmeter is always connected in parallel with the load. The resistance offered by the ammeter is always low, and for the voltmeter the resistance will be high. So practically the voltmeters and ammeters uses certain type of connections or internal design, and they are permanent magnet moving coil, moving iron instruments, hot wire type, and induction type. So in general, these type of instruments are used as ammeters and voltmeters in our laboratory experiments. So in general, among these, the PMMC and MI are the most commonly used type of instruments for voltmeters or meters. So with this, we come to the end of this topic, and the continuation of this will be seen in the next video. Thank you. Thanks for watching.